Computing devices that can sense the activity of users can be more reactive and intelligent in their interactions. mmWave Doppler radar is a new and promising sensing approach for human activity recognition, offering signal richness approaching that of microphones and cameras, but without many of the privacy-invading downsides. However, unlike audio and computer vision approaches that can draw from huge libraries of videos to train deep learning models, Doppler radar has no existing large datasets, holding back this otherwise promising sensing modality. In this work, we considered possible sources of training data, including depth camera and motion capture datasets, but these were much smaller than equivalent video data sources. In response, we set out to create a software pipeline that converts videos of human activities into realistic but synthetic Doppler radar data. Such an approach would offer an unparalleled volume of training data for this emerging sensing modality and future human activity recognition systems. The first step of our processing pipeline is to take an input video and fit a 3D mesh to humans in the scene. We can then position a virtual camera to synthesize any view of that user. This simple manipulation, essentially a form of data augmentation, means we get a multiplicative effect on every second of input video. Next, we estimate the magnitude of reflected RF and any induced Doppler shift by computing the radar cross-section and radial velocity of every vertex in the mesh with respect to a virtual Doppler sensor. We then perform backface culling and also account for any occlusion from the user. Now, left with only reflections that are visible to our virtual sensor, we can compute a holistic synthetic Doppler signal by summing all of the individual vertex reflections. The envelope of this initial simulated Doppler signal roughly follows that of actual Doppler data. However, the correspondence can be greatly improved with an encoder-decoder model trained with real-world data. This is the final output of our pipeline and what we use to train a convolutional neural network for activity recognition. Once trained, our model can predict activity using live Doppler data, as seen here. This model, which recognizes 12 exemplary activities, was trained solely with data drawn from public video datasets. Note that the video of the user, shown here, is for reference only, and our approach is only taking advantage of Doppler data for recognition. Please see our paper for full technical and study details.